In this video, I'm going to show you how to solve with a quadratic formula. And what we're going to be doing is specifically on a parabola, we're going to be finding the two places or one place or no places specifically that your parabola will touch the x-axis. And I would recommend this quadratic formula if you've used other methods and they don't work, meaning factoring or solving with the square root method or completing the square. Just factoring would be a little quicker, actually a lot quicker, and there's a lot of room for error here if you're not exactly sure what you're doing. And so that's why I recommend this function last. So I'm going to try to walk you through about 5 examples and just kind of give you a feel for what the quadratic formula looks like. So again, I'm going to first start with what is called the discriminant. So here's a reminder. The discriminant is the part that goes under the square root symbol. It's called b squared minus 4ac, and it can tell you a lot about your picture, meaning your solutions, where your x-intercepts, not where, but how many you're going to get. And if your discriminant in the quadratic, if the discriminant is positive, then you're going to have 2 real solutions, meaning 2 places where your parabola is going to touch the x-axis, very much like this picture here. But if your discriminant is 0, then you're going to have 1 solution, and if it's negative, then you're going to have no solutions. And if it is a perfect square, then your original equation could have been factored, which in factored is actually kind of easier. So I'm going to show you a few examples of each. So in this example here, I'm going to start with identifying my three parts. A is 1, B is the number in front of the linear term, so 12, C is the constant, meaning 3, and A is the coefficient in front of your x squared. I didn't say that in the beginning. So 1, 12, and 3 if your function is written in standard form. And now what I'm going to do is find the discriminant piece first. So b squared minus 4ac. In my case, I'm going to take 12 and square it, and then subtract 4 times 1 times 3. Now 12 squared is 144, and 4 times 1 is 4, 4 times 3 is 12. 144 minus 12 is 132. So because this is a positive, I know I'm going to get 2 real solutions. And so now I'm going to actually find what those are. So I am going to not do simplified radical form. I'm only going to teach you the decimal form. If you want to know simplified radical form, go ahead and ask your teacher, or subscribe, like, and tell me to do another one, but simplifying radicals. So again, I'm going to start filling out my entire formula here, and I have a big part of it that we've already solved for. So our solutions are going to be x-intercepts, and I'm going to start plugging in now opposite of 12, so negative 12, plus and minus the square root of what we just found, 132. And then we're going to divide by double of what my a term is, and my a term here is 1. All right, so first what I'm going to do is get the decimal for the square root of 132. So I'm going to take out my calculator. I'm going to type in the square root of 132. Now, if your calculator does simplified radicals for you, then that would make solving this pretty easy, but I'm not going to teach how to do that in this particular video. What I am going to do is just talk about how to solve the quadratic formula. So the square root of 132 really is the same as the decimal, 11 point, I'm going to round to 49. So negative 12 plus and minus 11.49, and then we're going to divide by 2 times 1 or 2. So now that I have this kind of 3 parts ready, I'm going to do one example here where we add, and the other example where we are going to subtract. So see how there's a plus and a minus? I'm going to do the add one here. So I'm going to take on my calculator negative 12, and I'm going to add 11.49. And I get, actually, I don't love this calculator because it likes to simplify for me. But when I add them together, I get negative 0.51, and then I'm going to divide by 2. So hit divide by 2, and I want the decimal answer. So where my x-intercept is going to be is at negative 0.255. So that's going to be one of my x-intercepts. And now if I were to have subtracted, so negative 12, but this time subtract 11.49, and I get the decimal negative 23.49. And then I'm going to divide by 2. So the other x-intercept is going to be at negative 11.745. So I am going to have two intercepts of my parabola. One of them is going to be really close to 0, and the other one is going to be kind of close to negative 12. So those are the two x-intercepts. And now let's do a few more. So in this next example, my header here is gone. So I'm going to write down that discriminant b squared minus 4ac, and then the quadratic formula over here. Opposite of b, plus and minus the square root of our discriminant that we're going to find first, all over 2a. All right, now first let's identify our a and our b and our c. So in this example here, my a is a negative 1, b is 2, and c is negative 1. So I'm going to start with my discriminant first, which is b squared. So 2 squared, and then minus 4 times negative 1 times also negative 1. So here, 2 times 2 is 4. Negative 1 times negative 1 is going to make both of those positive, and 4 times 1 is just 4, and so I get 0. Now with 0, that means I'm going to have one solution, and I'm going to show you why we get only one solution here. So now we're going to start filling out the quadratic formula. So opposite of our positive 2 would be negative 2, so that's what that negative means. We're going to make it opposite sign. We're going to take the square root of 0, and then we're going to divide by 2a, 2 times negative 1 here. All right, the square root of 0 is 0. And negative 2 plus or minus nothing is just going to be negative 2 over negative 2, which is going to end up being an x-intercept of, when I simplify, just the number 1. Look how easy that was when it was 0. Okay, here's another one. For my next example here, my a, oops, I didn't mean to do that. I meant to hit just to kind of zoom over on this side. Okay, my a here is going to be the number 2. B here is going to be the number negative 2. And C here is a 3. So the b squared minus 4ac part here, careful here, squaring a negative. Make sure if you're using your calculator, you use parentheses. We'll have negative 2 times negative 2, which is 4. And 4 times 2 is 8. And 8 times 3 is 24. And I'm going to get the number negative 20. So when you have a negative, I'm going to show you that you are going to get zero real solutions, or no real solutions. And I'm going to show you over here once we start filling in our quadratic. So here's the formula at the top of my paper. Opposite of negative 2 is going to be positive 2, plus and minus the square root of negative 20, all over 2a, or 2 times my a of 2. So this is going to be 2 plus and minus the square root of negative 20, all over 4. But if you have the square root of a negative, we're going to get no real solutions. And I want to show you on the calculator that you're going to get here, oops, let me clear that out, square root of negative 20. Notice it will say error on the calculator, and that means that you cannot do that because no number times itself is going to be a negative, and so simplifying that square root just isn't going to work. Okay, here we have one more. In this example, my a is 1, b is negative 3, and c is negative 4. And so let's fill out our discriminant piece first. And so this is going to be negative 3 squared minus 4 times 1, my a, times c, which is negative 4. And this number, negative 3 times negative 3, is going to get me positive 9. 4 times 1 is 4, and 4 times negative 4 is negative 16. And here, we're going to actually end up adding, because minus and negative means we're going to add, so 25. And I also want to say that because this is a positive, we are going to get 2 real x-intercepts. And because this is a perfect square, we really could have factored. So I am going to show you the quadratic formula, but then I'm going to factor this and show you that it would have been so much quicker. Okay, so here we go. X equals opposite of negative 3, opposite of b, so positive 3 because that's opposite, plus and minus the square root of 25, all over double a, double my 1 then. So I have 3 plus and minus the square root of 25 over 2. So over here I'm going to do the part where we add, and over here I'm going to do the part where we subtract. So it'll be 3 plus 5 and then in half, and 3 minus 5 and then in half, because the square root of 25, I don't need my calculator for that, but it's going to be the number, clear, square root of 25, it's going to be 5, and so here you'll see that we're going to add 5 and subtract 5. 3 plus 5 is 8, and 8 and half is going to be an x-intercept of the number 4. Now 3 minus 5 is going to be the number negative 2, and negative 2 divided by 2 is going to be negative 1. And I'll show you that we could have factored. So if we had x squared minus 3x minus 4, and we factor this. If your front term is 1, this is how I taught it. Write down your big X, you're going to take a times c, b goes at the bottom, and I already wrote down those numbers as well. 1 times negative 4 is negative 4. B is negative 3, that goes at the bottom. Tell me 2 numbers that multiply to make negative 4 and add to make negative 3. Well, it's going to be a negative 4 and a positive 1. And so to solve with factoring, you just set your factors equal to 0. So x would have been the number 4. And then if we, that's the bell, sorry about that. If we subtract 1 here, we get a solution of negative 1. It's so much quicker to factor than have to do all that work. But anyway, I digress. There is your quadratic formula. And stay tuned, in one more video, I'm going to do an application problem.